And we're back. Thank you for tuning in again to Mr. Laverick's Algebra 1 class. This is third period today. The time is 9:30. The date is March 9th. March 9th, 2021. The weather's nice outside. It's going to be a high of 65 today. It's going to be a beautiful day outside. So yeah, hope we're all doing good at home. Shout out Chance if you're watching. Chance, the code word is bananas. I will know you watched the video if you come back and say bananas. No one tell him.
You should do it at the end.
And we're all going to say, Cheers, what's code? And he's like, what are you talking about? I watched the video. What are you talking about? Hey, he won't even watch the video.
Yeah.
Come on. So, just to kind of talk through where we're headed, just so everybody at home knows what we're doing. We're going to go through the warm-up, and then we got 2 days on section 9-2. We're going to go through the homework, and then we got 2 days on section 9-2. Okay, we're going to have half the guided notes today, half the guided notes tomorrow. Okay, not a lot of homework tonight, numbers 1 through 12, and it should only take you about 5 or 10 minutes. No graphing on tonight's homework, which is nice. Okay, so make a table and graph. 1/2 x squared minus 2. Now remember, what x values do we always use? -2, -1, 0, 1, 2. If those x values didn't get you a full parabola, what would you do? Either you've done something wrong, or what should you do? You keep going, right? You keep making more x values, keep running more numbers to see the pattern. Okay? These will work, though. Usually they do work. Now, remember, let's plug in. Oh, I had a break. Oh, what did I delete on that? We've got, I'm going to put it in parentheses, 1/2. You don't really need to do that. And then -2. That must be in parentheses, and make sure you square outside of the parentheses -2. So we get 0. Let's do the same thing, but now let's plug in -1. And we get -1.5. We plug in 0. And we get -2. We plug in +1. We get -1.5. And we plug in +2. And we get 0. So those are my table. Make sure your coordinates match mine. And now we graph. I always say to use graph paper, so I'll abide by my rules. I'll pull a graph in. Shorten this up a little bit. Okay. Let's graph. Here we got -2, 0, dot right there. -1, -1.5, dot right there. 0, -2, dot right there. 1, -1.5 right there, and then a 2, 0. Now, should you just do like and be done? No. Fill the graph, especially if I give you a full 10 by 10 graph. Fill the graph with the parabola. Extend it on out. We want to go all the way over here. All the way over here. Extend out that pattern. Okay? That's what you should see. Questions on that? Guys, if you ever get something that looks like this, you didn't use parentheses correctly. Either you didn't use them all or you didn't use it correctly. You're not squaring it on the outside. So make sure you never get something like that. Question?
On a test, if we don't do it, fill the graph, will you take off?
I don't know. If I'm being really picky, yes. If I'm not, no.
Just depends on the day.
Depends on the day. Depends on, if you attach a piece of candy to the test when you turn it. That would be a bribe. That would never. And I don't take bribes from students. I'm just putting that on record. I don't take money bribes from students. All right. Number 2 here. Find the domain and range. Easiest question of the day. What's the domain?
All real numbers.
All real numbers. Well, use your x values. Okay, I like that answer. For the domain of any parabola.
All real numbers.
All real numbers. Always, no matter what type of parabola, the domain is always all real numbers. Could be facing up, facing down, y, 0, whatever. It's always all real numbers. Now the range depends on whether it's a minimum or maximum point. Do we see how this is a minimum point? And all points are above that vertex? That tells me that this is going to be a greater than or equal to. If it's pointing downward, it would be a less than or equal to. Let's take a side note. What tells me whether it's pointing upward or downward? What term is that called? The number next to the x squared. He's right.
The term degree.
I'm talking about the a term.
Oh.
Remember, the a value. We learned yesterday that's called the a value. The a value goes next to the x squared. It goes ax squared plus bx plus c. That's going to come into play today a lot. Now, the y is greater than or equal to the y value of that vertex. So since this is at 2 comma positive 1, since this is at 2 comma 1, the y value is 1. If it pointed downward, meaning the a value would have been negative, then it would have been less than or equal to instead of greater than or equal to. All right, take out your homework. I've got the key for the homework here. Make sure that you're checking your answers there. I would ask you to read through a lot of these, but I mean, there's a bunch of graphs on this that's an impossible way to do that. Number 22 is not quadratic. The common differences are not, the second differences are not constant for number 22. Number 23, I say yes. Can somebody tell me why I say yes for number 23? Oh. Because there's an x squared, exactly. Just simply, it has an x squared term. Side note, would that point up or down? Would point down because a is negative. Scrolling down, here's 24 and 25. In number 24, I would make a table to see what's going on there. You could have also plotted the points to see and just see if it was in that U shape. But we do see a constant set of second differences, so it is quadratic. And number 25, yeah, that is, I know we got some weird fractions going on, but I don't care about the fractions. I only care about the fact that I see an x squared term, so therefore it is quadratic. Any questions on the first four? Okay, taking a look at the next four. Now, here are my graphs for each one of those. Let me pull up here. Here's 26 and 27. Go ahead and take a look. If you don't have the full table and graph, like what I see on the screen right now, if you don't have the full table and graph on your homework, I'm not going to give you full credit for it, okay? I need to see the full table and the graph. So if you've already submitted it and you need to kind of resubmit, that's totally fine. Just make sure you put the full table and graph on your homework. So there's 26 and 27. Notice that the x values are always going to be -2, -1, 0, 1, and 2. The only thing that's going to change are the y values. And here's 28 and 29. What's wrong? You okay? You good? All right, and here's the next page, numbers 30, 31, and 32. What should you always make sure that it's in before you decide whether it opens up or down? Standard form, where it goes x squared, x, and then the constant, ax squared, bx plus c. Then you can tell whether the sign is a is positive or negative. So number 30, you don't have to worry about that. 7 is positive, so it goes up. Number 31, you got to subtract over the x and add over the x squared to get everything on the away from the y equals. So it ends up a is equal to +3, not -3. +3, so therefore it opens up. And then number 32, it's already in standard form because there's no b or c term. So it does open up. Oh, sorry, down. Negative opens down.
Thanks for not doing a lot of homework tonight.
I try to make it easier on you guys.
Only
The
one through
pilot
12?
don't even say that. The pilot work problem.
I try, I really care about my students and like their time, but that's why I only give you a little bit of homework.
A little?
A week ago, we had.
I was gonna say I won't go there.
So,
I won't
Say
go
it.
there.
No, I want to hear it.
I will go there.
No, just go there.
Yeah, that's okay. I was gonna roast you a little bit.
I want to hear this.
It's about me not doing a whole chapter.
Yeah, that's true. I don't think they did it anyway, so why does it matter to you?
Oh.
I think the chance will be organic. Yeah, it's like, it's not wrong.
He's not saying anything up here, he just roasted it. That's brutal. All right, there's 33 and 34. You don't have to say the minimum value is just a number. If you had said the coordinate as well, that's totally fine. You could say the minimum value is 0, -5. The maximum value is at 1, -3. Understand that the y value is technically the actual just minimum or maximum, but, and then there's the last 4. Notice how the domain is all real numbers. Oh, the range, it kind of got cut off on the TV, so look up there. All right, questions on any parts of the homework? No? Let me hand out the guided notes here. So we're going to do section 9.2, day 1 today again. Section 9.2 is where we start to pick apart the pieces, the important pieces of every parabola. Okay, like for example, what we're going to do today is talk about 2 very important pieces known as the zeros and the axis of symmetry. Tomorrow, we're going to talk about the vertex. Now, we've already talked a little bit about the vertex, but we're going to be able to identify it without even needing a graph. Yesterday, it was very easy to pick out the vertex from the graph. Like we did that in these couple problems up here, right? 33, 34. Do we all agree that it's very easy to pick out the vertex given the graph? I mean, come on, just pick out the point. Tomorrow, what we're going to do is, given the equation, figure out the vertex, okay? Now, to do that, we're going to need the axis of symmetry, and we're going to need the zeros to define the axis of symmetry. So let's start by talking about the zeros of any function. Now, the zeros of a function is a term that is not just applied to quadratics. You can talk about the zeros of any function. Doesn't matter. You can talk about them as zeros of linear functions, zeros of quadratics, zeros of cubics. If you talk about a zero of a function, what you're really talking about are the x-intercepts, okay? You're really talking about the x-intercept. Now, when I ask you to find the x-intercept, now we've done this. If I ask you to find the x-intercept of a linear function, say, that looks like this. Remember back in the day we said, back a long time ago, first semester, I said, if I give you this equation, find the x-intercept. Well, that would just mean I plug in 0 for y. And if it's truly in standard form like this one, you could just kind of like take that away. Divide by 3, x would be 4. So we would know it's at 4, 0, right? An x-intercept is always of the form number, 0, right? Where the y value is 0. Now, when we go to start doing this for quadratics, it's not that easy to solve. Like this one was really easy, just divide by 3. It's not as easy to solve when you go to find the zeros of a quadratic. But if I'm given a graph, it's very easy to pick out where the zeros are given a graph. Because all you're looking for are the x-intercepts. Okay, now, since the graph intersects the x-axis at the point, or points containing the x-intercept, those intersections are called the zeros. When I talk about zeros, they are synonymous with x-intercept. You know that word synonymous, right? Synonyms meaning the same thing, right? So if I talk about zeros of a function, those are the x-intercepts. Those mean the same thing. I can use those terms interchangeably. Zeros are x-intercepts. Now, a quadratic has either 1, 2, or no zeros at all. I'm going to draw diagrams of each one for you, and I'd like you to write them in the space provided. Okay, so let's take a look. Let's take a look at 1, 0. What's it going to look like if it only has 1, 0? Well, if it only has 1, 0, that means it's only going to have one x-intercept. Meaning, if it's a parabola, it's going to come straight down to the x-axis and just hit it once. Just touch it once. It's going to basically bounce off of the x-axis. That's an example of when it has 1 0. There is another case when we have 2 zeros, and this is the more common case. This is the one that we're going to see most often here in chapter 9. When we have 2 zeros. When the vertex is underneath the x-axis and it crosses twice. If it's facing upward. If it's facing downward, the vertex would be above the x-axis and it would go downward again twice. Taking a look at my third option, how is it possible that we would have no zeros at all? What would it look like then? Well, basically what's just going to happen is if the vertex is above the x-axis, if it's facing up. If A is positive. If A is negative, then the vertex is just below the x-axis and it goes down. So it's never going to cross the x-axis. Zeros are x-intercepts, where it crosses the x-axis. Do I care where it crosses the y-axis? Not yet. We'll get there. All I'm talking about is where it crosses the x-axis. Now, this term zeros of a function, it doesn't have to just be applied to quadratics. It could be applied to anything. Hey guys, take a look up here. This is not in your guided notes. Kind of going off script a little bit, going rogue. And here's why. Because the state test loves to give you questions like this. And they'll ask you, where are the zeros of the function? Where are the zeros of the function? Well, can anybody give me one of them? How many are there? Let me ask you that question first. How many zeros do you see? 4. 1, 2, 3. There are 4 zeros of this function. It crosses the x-axis 4 times. So I would say there are zeros at -1, +1, +3, +5. It's where it crosses the x-axis. Do I care about that one when I talk about the zeros? No, that is not a zero of a function. That is the y-intercept of the function. That's not an x-intercept, it's the y-intercept. Okay? Now, I just got done saying that a quadratic could only possibly be 1, 2, or no zeros. So is this even quadratic? No. We actually know by the fact that it has 4 zeros that this would be actually a quartic function. The degree would be 4. But you learn about that in Algebra 2. So find the zeros of the quadratic function given its graph. Pretty easy, guys. All I'm just asking you to do is pick out where the x-intercepts are. You just got to know that when I ask you for the zeros of the function, I'm asking you to find the x-intercepts. Where is one of the x-intercepts? Somebody tell me. Yeah, tell me. -1, comma 0. And where's the other one? 3, comma 0. Yeah. That's pretty simple, isn't it? I hope you think it's simple because we'll use that a little bit later on. Because all I'm looking for is the x-intercept. What would have happened if somebody tried to give me the answer of -3? What am I saying there when I say -3?
The x or the y?
The y-intercept, right. It would be incorrect because that would be the y-intercept, not the x-intercept. All right, so that's an option where we have 2 zeros. Let's take a look at the diagram where we would only have 1 zero. Well, where is it? -4, comma 0. Yeah, quite simply just -4, comma 0. We know that if it bounces off, it's only going to have 1 0. It's not going to cross again. And it bounces at -4, comma 0. Okay? Notice that if a parabola has only 1 0, the 0 is the x-coordinate of the vertex. Oh, that's a good thing to point out. Do you notice how, if it bounces off the x-axis, that point where it crosses, where it hits the x-axis is also the vertex point, right? That's true. Whenever it only has 1 0, whenever only has 1 0, the vertex is the 0. Does this cross at all? No. There are no zeros. There are none. Questions about that? So we're able to identify the zeros given a graph. We're not going to talk about the zeros given an equation just quite yet. Trust me, we'll get there. That's going to be like 2 sections in and of itself. But what we're going to look at next is this new thing called the axis of symmetry. Hey guys, what is a line of symmetry? When you cut it in half and the 2 sides are equal, basically, right? I mean, you've been doing symmetry since like grade school, right? You just draw a line down the middle and it folds it in half. Sometimes they're horizontal lines of symmetry. Sometimes they're vertical lines of symmetry. But basically a line of symmetry is one where you can cut it down the middle and the left side matches the right side. Let me go back to the homework assignment and let's take a look at some of those graphs that we drew. Do you see how I could draw a line of symmetry down pretty much every single graph that we did on the homework assignment and every graph that we were given on the homework assignment? Some of them were the x-axis, or sorry, some of them were the y-axis, but some of them were not. Like this one here is not the y-axis, but I can draw in a line of symmetry no matter where it exists. Okay, that line is what's called the axis of symmetry. The axis of symmetry, by definition, is the vertical line that divides the parabola into 2 symmetrical halves. It's a vertical line. It's always going to be x equals that line. X equals that line. You can use the zeros to basically find the axis of symmetry. So if there are 1, 0, well then obviously that vertex has to run through that axis of symmetry. Okay? So you're just taking the x value of the vertex, and that's where the axis of symmetry is. Okay? If it's got 2 zeros, then all you need to do, since I know the axis of symmetry cuts it in half, you're just going to find the halfway point between the 2 zeros. So like in this one, it crosses at -4 and 0. What's halfway between -4 and 0? -2. So x equals -2 would be my axis of symmetry. Okay? If it's got no zeros at all, then you're not going to be able to tell where the axis of symmetry is based on the graph. And you'll see here in a second why. So where is the axis of symmetry here? Be careful, -1. And also, I want us to say x equals -1. That's the full answer there. Don't just give me -1, it's x equals. Why am I going to be picky? I'm going to be picky because that's a line. It's a vertical line, and I want to reinforce the fact that any vertical line is an x equals line. X equals -1. And notice how the vertex is at -1, 0. The x value of the vertex will always match the x value of the axis of symmetry. Take a look at the next one. Let's draw in. Go ahead and draw in your axis of symmetry there. Where do you think it lines up? X equals what? 2.5? How can we know for sure? How can we know for sure that it ends up at 2.5? Well, where is that 0? That's at 1, 0, right? Where is this one? 4. What's directly halfway between 1 and 4? 2.5. Okay? Basically finding the average between those two. Average of the zeros. Okay? That's how we know for sure. Can you kind of ballpark it and eyeball it and see, okay, you got to go right through the center? Yeah. But if you got 2 zeros, then just find the midpoint of the zeros. Where do you think that one is? Looks like it's x equals 1, right? Let's check and make sure. This one's at -2, and this one's at +4. What's halfway between -2 and +4? 1. Find the average of those two coordinates. It's 1. And again, we're going to say x equals 1. That full answer is x equals 1. What about the last one? Where is it on the last one? -3. So I hope we see that it's very easy to identify the pieces and parts given the graph. Like if it's given the, if we're given the graph, it's very easy to identify where the zeros are and where the axis of symmetry is. Okay, very easy. Now, what if we're not given that information? If a function has no zeros, or it's difficult to identify from the graph where the axis of symmetry is, maybe it's a weird number. We can use a formula if we are given the equation. This is a very important formula that we're going to need to memorize. X equals negative b over 2a. That is what's called the axis of symmetry formula. This will give you the axis of symmetry if you're given the equation. Okay, this will give you the axis of symmetry if you're given the equation. It's negative b over 2 times a. Where am I getting the a and the b? From the equation, right? ax squared bx plus c. Is c included in the axis of symmetry equation? No, I'm not using c at all. Don't worry, it'll get its day. C will be used quite often. So that's actually a really important number that we'll learn about in section 9.3. But negative b over 2a. Negative b divided by 2 times the a value. That is the axis of symmetry. So let's try it. Find the axis of symmetry given the equation. All right. Every time we do this, these 3 times that we do this at the bottom of the page, I want us every single time to be writing out A equals, B equals. Because again, that's going to help you later. The process is really important here because when we go to use the quadratic formula, we're in section 9.8, you're going to thank yourself for doing this. And then we're going to write out the equation with the letters in it. Negative b over 2a. Why are we going to do that every time? Because that's going to help us memorize it. Okay, what's my a value? Negative 3. Dane, what's my b value? 10. Again, my c value I'm not going to use. I guess I should have started this way before even identifying. Is this in standard form? Yeah, you always got to make sure it's in standard form before you start identifying A, B, and C. All right, so let's plug it in. We got a negative out front. B is 10 divided by 2 times my A value is negative 3. All right, and now let's evaluate. That would be x is equal to negative 10 over negative 6. Do you notice how I've got 2 negative signs there? Negative, negative will cancel, leaving us a positive 10 over 6, which turns into x equals 5/3 as a reduced fraction, or 1.6 repeating, 1.67, whatever you want to say there. What does that tell me? That tells me that if I go to graph this parabola, the center line of this parabola is at 1 2/3, 1.6 repeating. Right? You go right 1 2/3, you make a dotted line down the center of the graph. That's the center line of the parabola. I'm not exactly sure where the rest of it is yet. But that's the center line, negative b over 2a. Let's try it again. Okay. All right, so we got a equals, b equals. X equals negative b divided by 2 times a. All right, what's my a value? 2. What's my b?
-1.
Negative 1, right. Whenever there's not a number sitting out front, you just assume it's a 1. All right, so we plug it in. We got negative b over 2 times 2. Negative 1 over 4. My 2 negatives will cancel, leaving me with a positive 1/4. Remember whenever I ask for an axis of symmetry, you've got to write it as x equals. You could give me 0.25, that's fine too. X equals. So if I go to the right a quarter and make a dotted line, that's the center line of this graph. Last one. I'm going to write A equals, B equals. A is 1, B is negative 4. X equals negative b over 2a, which is negative 4 over 2 times 1. Again, the negatives will cancel there. They don't always cancel. That just happens on these three. 4 over 2 is 2. So x equals 2. Make sense?
Sure.
So what have we done today? We talked about zeros, axis of symmetry, and well, just the zeros and the axis of symmetry, right? The zeros given a graph are pretty easy. We didn't talk about the zeros given an equation. We'll get there. The axis of symmetry given a graph, pretty easy. The axis of symmetry given an equation, a little bit more difficult. Little. Here is the homework